The so-called MM1 model is one of the most popular analytical models for analyzing a single line. Now, the MM1 model is also then essentially a set of formulas that answers questions about a waiting line. So the real challenge with using the MM1 model is recognizing which formula answers what question. That is the challenge that's being posed here with this question. Customers arrive an average of 10 an hour. Speaking of the MM1 model, the customer arrival rate is traditionally symbolized with lambda. Okay, lambda equals 10. That's actually what that fact is right there. Oh, and an average of 16 customers can be served an hour. Mu is the traditional symbol for the average service rate, and that is exactly what we're being told there. On average, you can serve 16 customers an hour. And before we go any further, you need these two numbers, lambda and mu, to make anything else in the MM1 model work. We want to know the average number of customers that arrive in a certain interval, in this case an hour, and then the average number of services that could be performed in that same time interval. And we want to check, sure, 16 an hour. Great, we're ready to go. Now, what actually is the question? What is the system utilization? Oh, that's easy. Okay, in the MM1 model, the system utilization is lambda divided by mu. It's that ratio, or 10 divided by 16, or 0.625 on my calculator, or in conversation, 62.5%. We would say that this particular system, whatever it is 62.5% utilized. The utilization is 0.625. Now the next question is apparently about the same system, because if you look, it's the same lambda and mu. Customers arrive at an average of 10 an hour. Yes, we saw that before. And an average of 16 mu. Customers can be served in an hour. Assuming the MM1 model, what is the average length of the line? Now here's where recognizing the different formulas becomes so critical. The average length of the line, capital L for length, lowercase q for line, q being another word for a line. That's the formula that reads lambda squared divided by mu over mu minus lambda. This is the formula we need to answer that question. Oh, okay. Now all we need to do is fill in the formula. That's what? 10 squared, or 100, divided by 16 times 16 minus 10, or 16 times 6. I get that is 100 divided by 96, or 1.04. We are talking about the length of a line, so that is essentially one customer. I'm just rounding a little bit more. This particular line, what we've determined is on average there's one person in it. This particular system, on average, there's one person standing there waiting to be served. Okay. And then the next question is apparently also about this same system, because it's the same lambda and mu. Customers arrive at an average of 10 an hour, and they're served at a rate of 16 an hour. Mu equals 16 an hour. Assuming the MM1 model, yes, what is the average number of customers in the system? Average number of customers in the system. This formula, how do you know which one to use? It's asking about number of customers again, like it was previously. This one was the average number of customers in the line. This one's the average number of customers in the system, so it'll be capital L, again for a length, but sub S for the system. This includes anybody that's being served. That's what makes it different from this question up here. All right, what actually is that formula? Well, you do take the average number of people who are standing around in the line, and you add lambda over mu. That's the formula. The average number of customers in the system is the average number of customers in the line plus lambda over mu, which means that, and this is pretty convenient, we could substitute in for LQ here lambda squared divided by, what is that, mu times mu minus lambda. But, we have that work from the previous question right here. So we would say, the 1.04 plus 10 over 16. When I do that, I get 1.67. These are customers. So for this particular problem, this particular system, on average, there's about 1 2/3 people in the system, in the whole place. On average, one of them is standing, waiting. You're probably wondering, well, wait a minute. If on average you have about one person in the line, then you have an average 1.67, 1 2/3 people in the system. How come on average you don't have 2 people in the system? Because isn't there the line and then there's the person being served? Okay, the thing we have to remember that this is an average, and it includes any instance in which the system is completely empty, and that's why there's a narrower gap than sometimes people would expect between so-called LQ and L sub S. But at any rate, if you can remember the two formulas, you just fill them out, and there are your estimates.